Thanks, Kavishka. Good afternoon, everyone. It's an absolute pleasure to be here, like at the podium. I know the break is just around the corner, and I'm dying for a coffee as well, but bear with me for the next 30 minutes, and I can almost guarantee that you will walk away with something new. So, without further ado, let's jump in. No need for introductions. So, before we dive into like the technical parts, different techniques and solutions and tools out there, I just want to make sure we have a good fundamental understanding of the ground truth, right? Why we need things like CI in the first place. Now, if WSO2 is the only place you've worked at so far, you might look at this and think, hey, who does this anymore, right? But the ground reality is a bit different. There's a lot of organizations out there, our customers, they spend a lot of time doing things like this, right? This is the old school waterfall inspired pre-release kind of integration. I like to call it the Big Bang integration because you work on different things and you try to integrate it. You set off explosion of problems that sort of ripple through time and space, right, for a while. And sometimes the amount of effort that you put in to integrating it can be bigger than the actual time that you spent on the actual feature, right? You might have noticed this if you work on a feature branch for too long and you try to come back and integrate it, things break. So the same principle applies. So the whole idea around continuous integration, is to make sure that we have a shared mainline and we keep merging into that mainline and pulling from it as we go on, right? But what makes continuous integration different from just pushing and pulling from like a shared mainline is we want to make an integration event verifiable, meaning you don't want to break something that's already there, right? You want to prevent regression, and you also want to make sure that you are enforcing some level of correctness, right? So whatever you are adding to the state of the world should be correct, and you also want to make sure it's reversible in case your verification didn't work out as planned. So that's all the theory for today, right? Just another fun fact if you're not aware, CI is actually rooted deeply in extreme programming. That's actually where some of these concepts around integrate early, integrate often come from. Right. Now this is a diagram you've probably seen far too many times. This is absolutely nothing new, right? Your traditional CI pipeline. You've got a couple of, I wouldn't say orthogonal, but when you do develop these pipelines, you would focus on breaking them down into separate areas, and then you expand on them. Again, nothing new, so I won't spend a lot of time here. Now, let's jump into the technical parts, right? Some of the tools that have evolved to run CI pipelines on Kubernetes. Now, before I dive into these tools, it's important to mention that Kubernetes is not like a silver bullet, and there's a lot of problems that come with trying to run containerized build pipelines on top of Kubernetes, and we'll discuss some of those in a couple of more slides. And running builds inside VMs, it's actually quite in certain scenarios, it makes more sense. For example, GitHub Actions on their hosted version, every job that you trigger is run on a VM somewhere. Because VMs are more isolated than containers. They're inherently more secure. They are a bit slow to start, they're a bit clunkier, but you can run something, you can run malicious code in it, and you can throw the VM away and you're done. It's a clean slate. You don't really get the same level of isolation with Kubernetes and running build pipelines in containers. Again, we'll revisit that in a bit. So these are my pick for some of the better tools out there for running CI pipelines on Kubernetes. So these would serve as a general framework, and all of these things, what they do is they just execute things in steps, right? You do the one thing, you move on to another, and in certain things like Argo workflows, you can build cyclic graphs, right? You can build very complicated workflows. And there's a bunch of other projects that I've actually built on top of Argo workflows. Things like Kubeflow, where you can run machine learning models and training workflows on top of Kubernetes. And another interesting fact here is some of you might know Choreo's build system up until like late last year ran on GitHub Actions, hosted on our infrastructure, but of course the control plane was with GitHub. But we've now started a transition to Argo workflows, and this is one of the problems that we encountered, right? So if you can guess, right, what the problem is it's kind of related to Inception if you haven't seen the movie. So the issue is we are now running a node on a virtualized virtual machine, and we have a virtualized container running in it, and we are trying to build another virtualized artifact inside of that, right? So we are dealing with 3 levels of nested virtualization, and with that comes a whole bunch of new problems. Especially if you're trying to build like a multi-tenanted system and you're trying to enforce zero trust. Now, if it's a simple project and you're building like 2 containers, these are not problems that you need to deal with, right? If you're building things at Choreo scale, or if you're building things, a platform for like a large enterprise where you need to make sure things are separated out, isolated from each other, then these are problems that you need to solve, right? So this is a classic Docker in Docker scenario, right? So how do you build a Docker container inside of a Docker container, right? So that is the reference to Inception. For the longest amount of time, this is how we had to solve it, right? Basically, we can't run a Docker daemon inside of a container because it requires too many privileges and capabilities that are only found in the host operating system, right? So you run it in the node on the host operating system, and then we put a sidecar in the build job, and we make it a privileged sidecar. So what that does is it allows the client or the Docker client running the Docker build inside the build container to use the Docker daemon that's on the host node, right? Now the obvious problem here is that the sidecar is now privileged, it's rootful, and it has direct access to a very vulnerable operation on the node, right? Because that is the Docker daemon socket. And if you can do a whole bunch of things if this becomes compromised, including privilege escalation, where you can jump out of the container and into the host node. And if you're dealing with something like Choreo, that is catastrophic, right? Now, again, if you remember, this was a problem of the past because we now have a whole new generation of OCI compliant image builders. So OCI is the Open Container Initiative. It's something Docker started and people have started contributing to it. And that lays down an open standard for how we build images, right? So it's things like image manifest. I won't go into the details because we don't have enough time to explain all that. But the idea is you can build an OCI compliant image. Docker is OCI compliant, but so are a whole bunch of other new tools. And as long as you have OCI compliant image, you can run it on an OCI compliant runtime. And every popular runtime, like runc, containerd, CRIO, which I also uses runc, use open the OCI compatible runtimes, right? So pretty much every Kubernetes cluster has a container runtime that is compatible with OCI. So the key point I want to get to here is that you don't really need Docker anymore to build a container. There are completely new and sometimes even wild approaches to building virtualized artifacts inside of other nested levels of virtualization. So one of them is cloud native build packs. Now Choreo uses this internally. If you've deployed an application, you probably have used this before. Now the way this works is it completely takes away the build from the user. It's a black box. The only input that you provide is your source code. And build packs work on these layered concepts called life cycles. There's a detection phase where it looks at the source code, the files that you have, and figures out if you're running node, and then figures out which version it is, and then figures out which package manager you're using. And then it moves that metadata into the build phase, where it has the built-in logic to install the dependencies and actually compile or transpile your source code, exporting an image. Now that's one way to do it. This is completely hands-off. There is also more complicated and varying tools like Builder and Podman. Now, you might have heard of Podman, but maybe not Builder. So Builder is pretty interesting in the sense it's rootless, it's daemonless, it's Dockerfile-less as well. So effectively, Builder allows you to build a container as a script. Now this is like a snippet from a much larger file, but you can just write whatever, it executes as a script, and you can just say build a commit, and that writes an OCI compliant image. And you can take that image and you can run it on Docker, or you can run it on Kubernetes or Podman. And that's where Podman comes into play. So Builder can only build containers. So Podman is sort of like a drop-in replacement for Docker. Basically, it's the CLI interface is the same for Docker and Podman. It just allows you to do things like run the actual image, troubleshoot it, execute into it, things like that. What you do with Docker. So there's a whole bunch of new tools out there. Not that I expect you to remember any from this table, but it's good to know that it is a growing class of new tools. Like for example, AppCo is just wild. I don't even understand how people use it. You can build something into an APK, and you can use that APK. I'm not talking about WSO2's APK, by the way. You can use that APK and convert it into an image through a command line tool. I can't really think of a scenario where that would be useful, but there are plenty of alternatives to running Docker today, which doesn't require a daemon and doesn't require root access and doing all those weird hops that we are looking at in the previous example. So that's a quick primer on some of the new things we are seeing in the CI space. Now let's move on to CD. Now with CD, I hear this a lot, right? People use continuous deployment and continuous delivery interchangeably, and most of the time we are not completely aware that these are actually slightly different concepts, right? For a lot of people, continuous delivery is the equivalent to continuous deployment. They don't really understand that there's a minor difference. So the difference is, one requires manual intervention, right? So with delivery, your pipeline looks like this. You build, you test, you deploy to some kind of staging environment, you run your acceptance or whatever tests. Again, I've only put one box here, but it could be a whole stack of tests that you run against it. And then you come to a manual approval gate, right? And that's where some actual human has to get involved, see what the changes are, and make a decision as to whether you're going to go ahead with the production release or not. And most of the time, once you go ahead with the production release, they also have to observe for a little bit and make sure nothing is broken and that they don't have to roll back. Continuous deployment, on the other hand, is the extreme end of that spectrum. Basically, if you merge a PR or a commit, it just goes to production, right? So you need to have absolute faith in your release pipeline to pull off continuous deployment, right? What that basically means is you need to have extreme levels of discipline, extreme levels of automation, and a whole bunch of ancillary tools around your release pipeline to make sure things are tested for regression, things are tested for correctness, and once you merge something or go ahead with an automatic production release, you have automated observability and monitoring tools in place that can also reverse and roll back in case something happens, right? AWS does this, for example, in certain parts where they sort of roll them out in waves, but you're not going to go to that extent. Again, I think what I'm trying to make abundantly clear is that there's really no one tool or like a silver bullet that will help you achieve continuous deployment, right? It is a combination of continuously improving your tooling, your discipline, as well as building an underlying platform to support something of this caliber. That's basically what Aziz was talking about earlier, right? So let's move on to GitOps and continuous deployment. Now, GitOps is nothing fancy, right? It's a buzzword used here everywhere. And even Choreo V3 there's a lot of focus on GitOps. But what it is basically you put a bunch of things in Git. You basically declare some specification in a Git repo. You put a GitOps controller in the middle, and then you have the actual state of the world. And this is, as far as I know, GitOps became a thing because of Kubernetes, because this is basically a Kubernetes control loop, right? If you remember from Lakma's talk. Just looking at the state of the world, looking at the drift, and coming back and reconciling the world to match your desired state. So some of the principles around GitOps is you make things declarative. It has to be because it's in Git. And it's self-healing because it's continuously reconciling, right? So the concept is simple, but when you do try to go and implement it, it can get a bit ugly and complicated, as we'll see. Now, before we go into GitOps and how you build actual continuous delivery or deployment pipelines, we need to talk about how we package stuff in Git, right? Now, by stuff, I'm talking about Kubernetes manifests and YAMLs, because you're talking about a Kubernetes native, modern kind of pipeline. You're not deploying to VMs. So the two that you've probably heard of are Helm and Customize. As far as I'm aware, Choreo and Asgardio, for example, use Customize internally to maintain our internal systems. And in the case of Choreo and private data planes, we actually use Helm to package up the system components when we deploy it onto customer environments. And I think other products also use Helm as well. But that's not it, right? So Helm and Customize, they've been around for a while, but we are also seeing a new generation. I don't want to call it a new generation. New class of configuration and policy languages popping up left, right, and center, right? You might have heard of Q and KCL maybe, but there are certainly more interesting ones. For example, Kawal YTT. I have no idea why they named it Kawal YTT or the reasoning is behind it. But basically what this does is it's like a superset on top of YAML. Right? One of the problems that we try to solve with Helm and Customize is that we want static output, but we have different inputs. We have variables. We need to run things through functions to sort of filter out data, to transform data structures and all that. So you can actually do that inside YAML with something like Kawal YTT. Right? There's a function there. There's a loop and a variable. And there's a data value file. If you know Terraform, that'll look very familiar to you. So you can just run that, and you get the static Kubernetes output, and that's all you need. And again, JSONnet, I think this came out of Google. It's very similar. It's really a bit more object-oriented than Kawal YTT, but it is sort of built on top of JSON. So it's like a superset around JSON. And by extension, it is a superset for YAML as well, right? So that gives you variables, conditionals, functions, and even error propagation if you need that, right? Because if you're compiling something down to a static file and something goes wrong, you want that error to come out. I won't dive into too many examples, but these are definitely worth checking out if you are working in this space. Now, back to the spotlight. Again, my personal pick. If you're building, GitOps controlled continuous deployment or delivery pipelines. Flux, I think, was one of the original tools in this space. They pioneered the word GitOps. Well, they didn't pioneer it by themselves, but they were one of the pioneering organizations behind that concept. We use Flux internally in Choreo, for example, to send out updates, over-the-air updates to Choreo private data planes that run on customer environments. We actually install Flux on the data plane, and Flux basically pulls the new Helm releases when they're made available. But there's a lot more complicated pipelining work in between that the SARI team takes care of, but I'm just putting that out there as an example. Argo CD seems to be what's gaining more traction these days. It's actually probably a better pick if you're just trying to build something for a project. It's got a growing community behind it. It supports things like rollbacks, roll forward capabilities, even things like canary deployments, blue-green deployments, and it's got a whole ecosystem of plugins just for itself. It's got a nice UI as well. We'll have a look at it in a bit. So this is a basic pipeline. So I'll walk you through this, right? So we've taken out the CI part. We've already talked about that. So effectively, how we used to build these pipelines is the CI pushes the image to an image registry, and then you also need another step. You need to take the new image tag and you need to update it somewhere in your GitOps repository, because that is the new desired state of the world, right? And once you do that, you just have Argo CD run inside Kubernetes. And what Argo basically does is it continues to poll your repository, right? You can configure it. It could be 2 minutes, it could be 5 minutes, or you can set up a Git webhook and let Argo CD know that there is a change and you need to pull it again. And on the other end, Argo just basically continues to reconcile the changes in your desired state with the stuff that's actually running in the cluster, right? So as a concept, it's quite simple, and it is eventually consistent most of the time, right? You can't push something into Git and immediately expect changes, especially if you don't have like a webhook or something of that sort. So whenever Argo polls and picks up the change, it'll go ahead and synchronize it with your Kubernetes clusters. Now, this is a slightly different way of doing it. It's becoming more popular, but this is a bit more on the asynchronous side, meaning if you're on a fence, this is more or less leaning towards the continuous deployment side of things on that spectrum, because now you have very little control over production releases, for example. So how this works is, again, the same CI image push. You push the image into a container registry, and instead of you going and updating your GitOps repository, for example, as in what we did before, what we do now is we put another tool out there called the Argo Image Updater. Now, Flux has similar plugins as well. Again, you can pick any of these tools and get the job done, so it won't really matter. I'm just using Argo as an example. And again, just like how Argo would poll for changes in Git, it would now poll your container registry for changes. And the reason this is eventually consistent is there's no guarantee, right? Just because you pushed an image out into a container registry, there's absolutely no guarantee that the deployment will start in the next minute. There's a chance that the container registry or the provider behind it might have rate limited this polling function, so you might be looking at a delay of a couple of minutes. So this is why I said this is more towards the continuous deployment side of the spectrum, where you have to trust that once something has been merged, it's going to eventually make it into your environments, and then you need a whole bunch of other ancillary tooling and observability functions to make sure that this happens without causing regressions and setting everything on fire, right? So again, coming back to the diagram, you poll for updates. When there is an update, Argo itself can write back to your GitOps repository, right? And once that is updated, the flow that we had in the previous diagram kicks into place, and it gets deployed, right? So you're stepping back a bit more in configurations like this. Now, this is where it gets complicated, right? We looked at a very small but basic example. We take a bunch of YAMLs and we deploy it to Kubernetes, and we just do it through Argo. Sounds simple, but in reality, you need a lot of other things. For example, you need to have environments, right? You need to have promotions between those environments. So one way to do it again, as an example, is Argo gives you this thing called a post-sync hook. So once your dev deployment is done from the previous step, you can use that to trigger an Argo workflow, again, coming back to CI, to run a bunch of end-to-end tests and acceptance tests, regression tests and whatnot against the environment that you deploy to. And once that is done, you have two options, right? You can either have another workflow. This is what we do internally as well in a lot of places. We create another, we copy the values, the images that need to be updated from dev to staging to prod, and we just create PRs. And someone goes in, manually approves it, and merges it, in which case it gets merged to the GitOps repo, and we are back to that same cycle here, where it just picks up and continues with the prod release. Or there are new plugins out there, for example, this Argo GitOps promoter, where you can just basically declare that I want my dev environment to be stored in a branch, say environment/branch, and I want my production environment to be in, say, environment/production. And once this plugin is active, it will actually go ahead, create a PR for you in your GitOps repo when the dev deployment is done, and it will even go ahead and automatically merge that PR, triggering a production release, right? So we're seeing a lot of new techniques emerging in these domains, right? And there's a whole ecosystem of tooling and plugins that are being built around these pipelines. And that's like the Argo UI. It gives you a good idea of what's running, whether things are out of sync or they're being synchronized. But all this said and done, there is this slide that I did want to cover, and we do have time, so we'll have a look at it. So everything we looked at so far is around AppOps, right? Application operations. We didn't really consider infrastructure up to this point. Now there are more traditional ways of doing it, like you run Terraform outside of your GitOps repository, because Terraform, while, you could call it GitOps, but you still need to build a lot of pipelining around it to actually apply those changes in. There are new tools out there like Crossplane, for example. So like how Terraform gives you different APIs from cloud providers as modules, Crossplane converts all these provider APIs into CRDs, custom resource definitions. And what that allows you to do is you can chuck a YAML, a custom resource definition for an RDS on AWS, for example, in a GitOps repo, and just have your same Argo CD deployment pipeline, pick up that change, and have it resolved the actual state of the world in AWS. And there it gives you a lot of convenience functions, like it'll write the connection credentials if you're creating an RDS for the first time into a Kubernetes secret. And your deployment or your application can refer that secret and just connect to RDS. Now, it's not as simple as this example, but I hope you get the general idea. Now, on to closing remarks. We've covered a good breadth of these topics, but we really haven't, gone deeper into any of them. As you might understand, it's a vast domain, right? You have to sort of pick and choose what you need, and you have to also figure out how to build the right abstractions and golden guardrails for your developers if you are building a platform, right? This is where DevOps, the principles of DevOps sort of transition into platform engineering, because if you go ahead and build all of this, it's fine, right? But if you ask your developers to use tools like this as they are, you won't really get a lot of work done, right? Because you now need to learn how to work all of these tools. And it's just 2 tools, right? We've covered like 5 already. And in a production scenario, you're looking at probably dozens. Like that slide Lakmal showed you, it's like over 500 tools in the ecosystem, and you have to figure out which ones you need and how you're going to integrate all of that to sort of build out a production-ready platform, right? And there's a whole bunch of things that we haven't covered, like secret management, observability, and monitoring, things like how do you run a canary release or a blue-green deployment. And you need those things to really embrace continuous deployment, right? Because you want to be safe and you need to be confident that your release pipeline can get the job done without you getting involved. And things like disaster recovery, multi-regional deployments, parallel promotions, it's a whole bunch of problems that you need to solve. And this is where sort of the case for things like Choreo come up, right? Do you really have the resources and the time to invest and build something of this sort and maintain it ad infinitum? Or would you just rather use something like Choreo, where all of this becomes platformless, right? So that is it. We've got 30 seconds left. I wasn't expecting 30 seconds to be. Any questions? All right. Yep, I'll take that as a no. If you do happen to come across a question, feel free to come and talk to me. I'm happy to have a chat. Yeah, that's it. Thank you.